So question 11 says perform the indicated operation, write the expression in the form of a plus bi. So notice how this refers to a complex number. So a complex number has the first part represents the real part. So A represents a real number. And then this bi, where B is the coefficient of I, this bi represents an imaginary number. So remember, I is the imaginary unit. So this is the imaginary unit. Now, what we learned is if there's a negative inside the radical, this will not be a real number. This will be an imaginary number. So what happens is we know the I can already come out of the problem as so. Because remember that the imaginary unit is actually going to be rewritten as I squared equals -1. So since there's a -1 inside the radical, the -1 is going to turn into an I squared, and that I squared is going to come out as an I. So to cut to the chase, if you see a negative inside the radical, that's going to indicate that the imaginary unit's present and we bring it out in front. So the next thing is we have to simplify the square root of 48. So to simplify the square root of 48, we can use our prime factorization strategy: 2, 3, 5, 7, 11, sometimes 13. And notice that 2 does go into 48 because half of 48 would be 24. And 2 would go into 24 because half of 24 would be 12. And 2 does go into 12 because half of 12 is 6. And 2 goes into 6 3 times. So again, we just pull out a bunch of 2's. And then 3 is a prime number, so 3 is going to go into 3 one time. So what this tells me is for every pair of 2's, I'm going to bring 1 2 outside the radical. So since there's 2 pairs of 2's, that means I'm going to bring 2 2's outside the radical. Well, 2 times 2 is going to be 4. So this I squared of 48 is now going to turn into 4i square root of, and then what's left is this 3. So we would have that going on there. So if I use the calculator, since my calculator is already in complex number mode, if I do the second square root of -48, it'll give me, notice how it's got this little I on the end. Now notice you can also write this as I squared root of 48 because you do have the imaginary unit here above the decimal point. So notice how there's this I here. So you could type in second I square root of 48 as well. And notice how it gives me the same thing. Or if I type in 4i square root of 3 or second I second square root of 3, that gives me then the same answer. But again, in our MATLAB, they want the exact answer and they want it simplified. So they're looking for this answer because they want the perfect squares pulled out of the radical as well. So not only do they want the I pulled out, but they want to identify the perfect squares that are inside there and pull those out as well, so they can become a whole number on the outside of the radical symbol. So that's what they're looking for in question 11. But notice how you can check your work as they all give me the same decimal. So that since they're all equivalent, they all mean the same thing. But again, this is the one they're looking for as simplified.